Okay, welcome to our Kubernetes Platform demo. I'm Toby. I'm happy to introduce you to the Kubernetes Platform and show you a little bit insights and explaining what is the basic concepts about our platform. So first thing I want to explain to you is what is Kubernetes Platform about and what's the different to the normal Kubernetes distribution. So currently we see us as a highly automated cloud native platform what enables you to providing cluster as a service in a self-service platform approach and managing everything what is needed around this Kubernetes platform for you. This includes a lot of ecosystem tooling, what helps you to build together your platform as you want to do it. So we think it's important to have the flexibility to start with something and helping to build up once together something great. So for example, we can like have different kind of clouds included. So by default, you have like a different layer of separation in our platform, what automates your operation. So this helps you to really focusing on what's matter, and that should be your cloud native workload. And for that, we abstracted the different infrastructure layers. So on the down, we have a list of cloud providers what we support. On one hand, we have a unique layer built around that based on the Kubernetes upstream project, what's called Cluster API. This abstracting really the infrastructure provisioning nicely and is really adapting the Kubernetes core principle, describing something and creating an infrastructure unique layer around. And if you describe something, a controller takes care, so-called operator, also to create your infrastructure. In this case, on the cloud side, we have the public cloud providers for AWS, Google Cloud, Azure, or some not mentioned here, but also supported ones like Alibaba Cloud or DigitalOcean. On Promise side, we also can do the same thing. So we see also on-premise as a cloud provider. So in there you have something like maybe your OpenStack or your vSphere or some bare metal nodes. From the bare metal nodes perspective, you have multiple options. You can use bare metal as a service by the packet, or you can use KubeVirt for hosting your fully bare metal based virtualized cluster solution on your data center on the edge or wherever you want to do it. Additional to that, if you want to run some like uncommon workloads, for example, ARM devices, we're supporting kubeadm provisioning as well. That means you can manage your cluster with Kubermatic and joining your ARM nodes by your preferred provisioning tooling by executing kubeadm join command. If we have the infrastructure created, we have a kind of cluster as a service operator, what helps you to operate your cluster control planes with dedicated features, with dedicated upgrades. Everything is managed by the cluster as a service operator. For example, on the upgrade path, it updates 10 clusters in a row to reach the next patch version. Kubernetes platform from Kubernetes is designed to like hosting around thousands of clusters. So that could be scaled up as much as you need. So currently, there is no limit. It's just a matter of how you design your basic architecture. We will come to it soon. On top of the regular Kubernetes layer, we also have the app operator level. There, we providing with kubectl a service catalog solution where you can add in your service on demand if you want to provide some service as a service um, based on your platform and making money of it. For our customers, are could be like internet service providers, could be enterprising, or could be a small edge scenario. Everything is supported by Kubernetes, and how we can, for example, deal with dedicated clouds, different locations, and providing the same ID there, like having one unique layer around every cloud is the term what we think about. Here we have support for all well-known identity providers like LDAP or GitHub, Google. Everything what's OpenID compatible could be integrated. as well as some monitoring logging for your infrastructure and in-cluster monitoring and logging. Together with our API layer, so everything what you can manage with our platform is available by default also over an API. You can somehow automate your SRE workflow, and I call it sometimes KubeOps. So you're operating Kubernetes with Kubernetes, and therefore you can really focus on your core business, and that's running or providing your services. Cool. Another thing is the billing and accounting. So if you're running it in your enterprise or as a service provider, you want to figure out, okay, what costs get created and do some metering and helping you on the accounting side. That's also provided by Kubermatic. Cool. Then before we going into demo, I want to show you the basic architecture. So everything starts with Kubernetes. So first we're creating one Kube1 based Kubernetes cluster. This must not be Kube1, but it's recommended from us. It's creating a single cluster nicely and easy also with cluster API. Nevertheless, we then install then here Kubermatic as a Kubernetes native application, what's hosting an API server, an UI, and a controller and a set of controllers, to be honest. So if I create then a new cluster over the API or the UI, the new called cluster CRD get created here in the master cluster, and the controller starts to spinning up a user control plane. This user control plane is containerized, so that's one of the key differences here. If we are running an HA cluster as a VM, we basically consume per node 2 CPUs and around 6 GB of RAM, depending on the size, how much safety you want to have. If you're running a containerized control plane, we can make a HA setup in comparison to it with a whole consumption of 0.25 CPU shares, 2 GB of RAM for like a replica set of 3 decided control plane. Here we see that the power of containerization also starts in the control plane. So if you compare to the VM-based approach, you're saving only here at this part a lot of resources, like we counting about 5 CPUs and 10 to 15 GB of RAM. If you calculate it up to 10 or 100 cluster, it's really a big difference in a high level of scale. After control plane is provisioned, containerized, we install their so-called machine controller, what then provision the worker nodes. This worker nodes then get provisioned by an API call from the machine controller to the dedicated cloud environment, what provisions the machine freshly, creating the user data and then joining the cluster. The same approach will happen on an upgrade. So if we schedule an update, we follow the immutable infrastructure principle. That means we're only creating new resources. We don't never delete something, so or modify something. That means if I take an upgrade first, control plane, create a new control plane instances of Kubernetes, and then after this is healthy, we creating new nodes. That means a new Kubernetes node is joining the cluster, the old one get trained automatically. If you're now looking in this architecture, you see a lot of other clouds and other clusters. What is this about? So basically, that's the easiest setup, what you can run also with our community edition, and helping to managing on one location, on one data center, your clusters. Just to make it clear, the nodes must not be in the same data center as the control plane. So that means you can run your management layer, for example, on your on-premise environment, and only place the worker nodes in the cloud. In some cases, you have maybe a more distributed setup, and then you need some called seed cluster. Therefore, you only need to open one HTTPS point here to this, again, based Kube1 seed cluster. And therefore, if we create now a cluster in OpenStack, so Kubernetes API talks with seed cluster API, say, hey, I need a new cluster in the OpenStack environment. Then here the cluster controller takes over, creates again a containerized control plane. The machine controller again talking to the OpenStack API and creates the workers and managing the whole lifecycle of this cluster in this particular data center. This concept is really nice for data separation. So every data, what should be in one data center or one region, could be managed by a seed cluster, and it helps you to design your architecture based on the needs. Okay, so I think that's mostly clear. So let's go to the feature overview a little bit of our highlight features. So basically, what I really like most is that we have a self-service platform. So it's really changing the approach how you're managing cluster, how you're acting as a company. So here, you don't rely on tickets or some workflows. You basically consume a cluster from every cloud or supported on-prem environment when you need it and how long you need it. For that, also the auto scaling feature is nice, because then I just not can auto scale on public clouds. I can also auto scale on on-premise workloads. That's really something outstanding, because then I can use my maybe expensive resources of my on-premise data center in the best possible way and ensure that we don't like spend money for something what doesn't bring any benefit. Good. The next thing what I want to point out is we're running a plain vanilla Kubernetes cluster that you see also in the upgrades. So if a new Kubernetes bug fix release get published, we can immediately roll that out to all of our clusters. Therefore, we have an automatic upgrade approach. That's kind of our high-level automation, what helps you to manage your thousands of clusters if it's needed. So therefore, for example, if you say, okay, we have like for 1.18 a new bug fix release and all other minor bug fix releases are unstable, we just can configure it in a central position and say, oh, please Kubernetes, upgrade all my clusters. Then Kubernetes will upgrade 10 clusters at a time, and your data center is safe in the latest bug fix versions again. Okay, so what else? So we have a multi-tenancy, what helps also to providing a white label solution to your end customers. So therefore, by default, every component what you get from Kubernetes is multi-tenancy able, and you have a dedicated user management where the users itself, can, as you will see later, can decide who get access to my cluster, who won't get access with different levels. So you have a project level, which is a set of clusters, you have a cluster level, you have an in-cluster namespace level. And some call it microcluster approach. So we believing a separation by cluster is really hard. Helpful because you, for example, if you are working with CRDs, a CRD is unique per cluster. And if we want to really have dedicated environments, it's easier to create dedicated clusters and managing in the same way, in the same automation. Also really cool is the automated health checking and house cleaning. That means if I, for example, see that something went wrong, all the controllers, for example, a node get unhealthy, recognize it, and after a while recreating a new node and self-healing the infrastructure. Or we have a problem with our resources of the control plane. The controller tries to repair everything by automatic as much as possible. If something breaks, you get an alert and you will see, oh, there's something ongoing. The chances are that it's get repaired by itself, but if not, you get an alert of it. Okay, cool. Some other features we'll see in the demo, like for example, presets and cluster blueprints, where it's able that you can like predefine in operation center what is a default cluster and how you can extend different clusters. Good. So yeah, so let's go to the installation. When you want to start with Kubernetes, please just install first a cluster with Kube1 or any other Kubernetes provisioning, and then you can install Kubernetes on top of it. Therefore, we have an installer what you can download. Then you need to prepare a little bit of configuration, creating a storage classes, what is needed for the etcds to host it, and then you're running your installer, creating a DNS record, and you're ready to go. Everything therefore you can find in our documentation here. If you go to docs.kubernetes.com and then to the latest version, what's 2.15, and opening the installation page, you see the different kind how you can install it. As you see, we have a CE and an EE version, but nevertheless, everything what is about Kubernetes platform is open source and is also visible at GitHub. if you want to see it. So feel free to reach out to us and see what it's running here and helping us to improving the platform. Cool. So let's go to our demo environment. For that, the first step, what's normally do is to sign in. So that's the identity management starts. We have here different options to sign in. In my case, I use the GitHub authentication. In other cases, you can also use any other kind of authentication. Cool. Then log in here. And first, what we see is a list of projects where you can manage a set of clusters. As an admin, you can also see all projects um, if you want to. I'm managing a lot of projects. So here we go now to our cluster and going to our project and managing our clusters. Here you see I already provisioned a set of different clusters in different environments. And that's how we can now manage the clusters. If you have a team, like you are a development team, maybe want to add a people here, and that's pretty easy. I can add their email address, identifier, give in different roles or views, and for example, can create clusters. Viewer only can view clusters. Owner can also add different peoples to it. Um, Everything else, what you see in the UI is available over the REST API. Therefore, you can create so-called service accounts to manage your clusters based on some CI/CD solutions. And this token can then be used to talk to the API. So just to explore a little bit shortly the API, you can go to this endpoint REST API, and then you see this Swagger UI. For example, if I want to get a list of all the projects I manage here, I can try it out here and say, okay, please display only my project, executing it. And then I get back a list of projects like here, my different clusters, who is added there, and what's the ID here. Okay, so here is my demo project, what I used here. So let's copy this ID, and then I show you how the cluster API works for the cluster management. So here we see that we can create clusters like that. There also we have the parameters included, like project ID, data center, and a body, where we can then specify the cluster. The same is working here to get clusters. It's a little bit easier to show you. Like here, I can try it out and entering my project ID, executing it, and then I get a list of my already provisioned clusters, and I see, for example, what's the version, what is the endpoint for the clusters, and what cloud is this managed, and so on. Cool. Then let's create a cluster. So for that, in the cluster control plane, you can simply add create cluster. Here you see a set of cloud providers. That is configurable the same as the data center. So everything what you see here, you can decide what should be available for your customers or your internal departures. For AWS, we have here these regions. There also you can just enable the region what are routed to your maybe backend or something like that. To show you how the AWS and vSphere comparison looks like, I just show you the AWS dialog, and then creating a new demo cluster and showing how this is working. So we have a Kubernetes versions here provided, where you can freely choose whatever cluster you want to provision. Let's choose that one, and what kind of administration plugins you want to create. For example, the pod node selector plugin, and I want maybe also auto logging to have enabled. Another thing is like labels. There I can give some information like cost center, where I can add, okay, this should be calculated on the cost center 1, 2, 3, 4, 5. And that's demo cluster. And then I gave the cluster a label, what's called type demo. So I can then filter out that in the metering and in the accounting. Additional to that, I can also add SSH keys if I want to. This can place automatically on the worker nodes, but I don't need to. Cool. Then the next step you see here, we have access IDs and secret key for the AWS, and we have a so-called provider presets, what I get automatically then some kind of this configuration configured. In AWS, we see then the list of we predefined access key, the VPC, and then all the rest get created automatically. Because much more complex is the on-premise world where we don't have much load balancer and everything else. I wanted to show the vSphere use case. So there we have the data center in Hamburg. That's our small office vCenter, nothing special, just a regular vSphere. And if we want to create that one, yeah, we can do that. So like now, demo new cluster, we already selected that one and we can create it now. For here again, you see it's pretty similar to AWS. It's just a different set of authentication. Like here we have username, password of our technical users, and we have network configurations for the configuration of vSphere. So here I also choose the preset, and I can then create a new node pool. The new node pool, I give then a name like demo node pool, for example. And we want to have 2 replicas and creating flatcar nodes. Why flatcar? Flatcar is one of the smallest OS what you can use and is highly optimized for container workload. All others like here also Rail and Slash are supported as well if you something needed like that. Here I can do some configuration like CPUs and memory and maybe some more disk capacity wouldn't harm, so I can add it here as well and creating now a cluster on demand. So after get the summary, I can now create my new cluster and see what's happening. First step is creating a containerized control plane. What is displayed here with APIs, FCD, machine controller, and scheduler. If you're going to the admin side, you can also during the time waiting for the provisioning, I can show you the admin perspective. Here, for example, we have Prometheus running and we're getting maybe some alerts. Like here, we have the Kube API latency for some user classes are too high because maybe my hosted nodes are currently have some AO issues. So it's not like really critical, but I get at least a warning. Cool. That's like something from Prometheus. You can do whatever you want to it. What's maybe more interesting is the monitoring dashboards. For example, if I want to know how much clusters do I run and how are they provided, and I can see here, okay, are running 2 vSphere clusters, 2 AWS clusters, an Azure cluster, and KubeVirt cluster, and you bring your own device cluster. That's our KubeADM cluster, and here you see also, okay, how this is developed and getting some data out of it, what versions have been used and what time. Cool. Then other thing what I can see here is for example, the resource usage of my master cluster where I hosted my containerized control plane. Here you see we kind of managing this 8 clusters with 6 CPU shares and 2 GB of RAM. And if you take a look here in the data, come on, Grafana. Uh, sorry for that. You see that the cluster here consuming 0.25 CPU shares, and we see here down also the memory usage. That's something about, close that one, also close that one, like 1 to 2 to 3 gigabyte, something around that. So on average are 2 gigabyte, and to point it out, it's really an H8 control plane. Okay, now I think we are ready to see our cluster here. We see already the machine controller running, so it just should take a few seconds. Then we should also have the other components up and running and can start with the cluster provisioning. Okay, it seems only that D is now missing. So let's see. So it should come up quickly. And then after everything is provisioned, like I said, it takes around 2 minutes. And depending how much capacity is currently there, we can then create like our resources. What should be there hopefully right now. Okay, give in a little bit time. Um, Yes. So now we are ready to go. So we see now that we have created a cluster and it's running. Okay, then we also see that now the node pool is coming up. So we now provision a new node pool and the class get created. What's nice is we already can connect to the cluster and managing the cluster and opening the dashboard. In this case here, we reaching out the dashboard or our internal C cluster. So even if your worker nodes running on premise in some isolated network, we can ensure that this dashboard is reachable through our education layer of Kubernetes. Just to make it clear, Kubernetes is not needed to run Kubernetes clusters. So if Kubernetes is somehow would have a problem, then nothing is affected. Basically, the UI maybe is not possible, but it's all about. So you see now here we have our control plane and of Kubernetes, and we see there's currently no nodes. So now the nodes get provisioned on vSphere, and we see already that we have 2 machines provisioned, and we get somehow soonish an IP, and then the machines will join the cluster. As long as this will happen, our vSphere is not the fastest one. We can add maybe some, like for example, I want to give my colleague Manuel also admin rights to this cluster, so I add him here, luce.com, and give in here the cluster admin rights, for example. The other thing I can do here is like providing the services. Here we see the add-ons. That's the same as the service catalog. Basically, you can there install additional workload to your cluster. In our on-premise world, we can now enable a few things. What I really like is the cluster autoscaler. So this is a controller that automatically scales down, up and down your provision machines. So let's create that one. Also, we need somehow a traffic to our workload. So currently, like on premise, you don't mostly have a load balancing solution like in the cloud available. So therefore, we often are using metal IP. Therefore, I need here a cluster IP, and this cluster IP, let's get shortly it. Would then used as a virtualized IP in my cluster. So in our case, let's use that one. Um, and yeah, so I can get like 2 type of load balancer for this routed IPs. Okay, let's install the metal IP. And what else do I need? So I need an Ingress. So I want to expose my applications to the outside of the world. I will install an Ingress. Also, what's possible to install like add-ons for your monitoring and logging stack. Here, let's install the Ingress. And yeah, 3 replicas should be enough. And then if we go back to our dashboard, we will already see in the namespaces that we have now a few new namespaces like our metal IP system, where we will see that some pods will schedule as soon as their component of the nodes are there. Next is the Ingress here as well. After the components are up and running, we see that the components will start. Cool. So basically that's then the provisioning part, and we just need now to wait to that our nodes get provisioned. So let's see where status. This could take a few seconds after they get joined. Okay, so the first node is up. Then let's see. So cool. So then we should also see that the Nginx get deployed and get scheduled. So let's take a look at it. So we have here a few nodes, and then the nodes get scheduled for sure soon. Okay. Here you already see that also the servers get provision. So the next step would be now that we can reach now our ingress about this service URL which just appeared. Good. Then if we go here, you see that's the site is not reached, so that means that the pod of the ingress is just scheduling. Um, you now see the ingress is booting up, and the container get created. As soon as they are healthy, we can reach our service. So the last thing I want to add is a demo application, what's called Echo Service. What can we deploy after the Ingress? Let's deploy that one. Let's say 3 replicas, Ingress parts, Echo. Yes. Also, I want to show you here how the upgrade is working. So as long as it's scheduled, you just can say, okay, we now want to scale up our application and want to patch it. So let's say you want to scale up to 3 and also want to upgrade the control plane. That's something where our power of the system came in place. So we say we have a declarative way to define our clusters. In this way, we say, okay, that's the control plane version X, and then the control plane, the Kubernetes version of the worker nodes is this version, and then our controls take care for the upgrade. Nevertheless, what's the address get applied. So here we see now that the first thing what will now happen is that the control plane get recreated or not recreated, get updated. Behind the scenes, we create a new containerized API server joining the cluster and removing the old one. The same we will do with the machine deployment. We will see it as soon as the control plane upgrade is in place. Nevertheless, we say we can see here that the containers are get created, and after they are pulled, you see here that's running already. We should be able to get our service already. Here we see also the echo service what get deployed here as well. Okay, let's see if it's now reachable. Um, if it's now reachable, yes. It's not. Let's see if I what's going on. Oh, this was the wrong engine X we would want to use. Um, yeah, so we should have some endpoints. Ah, here we go. Yeah, and now you see, okay, we are reaching our ingress, and on the echo, we reach our echo application. After this one is upgraded as well. Uh, let's see what's the problem is here. Yeah, maybe it just takes a little bit. The echo service is deployed, and we have an ingress here, what's called echo service, and it should be available right now. So yeah, let's see what's happening now. It just maybe was too it was just a timing issue, and you see now we're getting back here our echo service from what's deployed on the node. It's just a simple demo application what gives you some more information about what's deployed on the work node. Cool. So let's see how many nodes we are now have. So we see that we have now 3 nodes running. Already a new node get joined, and this one could be the new one what we upgraded. So we have 3 nodes now in place, and we have after the 3 nodes, we have 1 node with the new versions what get not booted in a rolling upgrade. So as soon as this is updated, 1 node get trained. So we see that's now getting booted after the node is ready. The old one get removed, and we have a rolling upgrade of nodes. Okay, that was basically our demo. As you see now, we have a new healthy node, the old one get trained, and a new node will join with 18.10. So thanks for your attention. Looking forward to hear some of our questions.